Hey guys, how are you all doing? How's your day going? And if you're just starting, how's your night? Hope you had or are having an amazing and a beautiful day. This is day 12 of our 100 days of Python, and today we're going to be jumping into a more intermediate level type topic. Today we're going to be covering object oriented programming, which I believe every single person is familiar with. So we're just going to try and brief through it. Like, I'm trying to simplify it so that you'll be able to understand all the concepts, be able to apply it and implement it, but not get too confused because it's a bit bulky. But basically, in programming, there's this stuff called paradigm. It's an approach to programming and coding which offers guidelines for designing and implementing software systems. Now, in programming in general, there are multiple, there are like different types of programming paradigms. You have procedural programming, functional programming, declarative programming, logical programming, event driven programming, concurrent programming, and object oriented programming. So when we're working with Python, every single thing we do is usually considered as an object. This means that Python implements object-oriented programming by representing data and behaviors as objects that can interact with one another. That is, we take every single thing we're doing and treat it as like you will a real world problem. You get. This allows developers to create more complex data structures and algorithms that are reusable and easier to maintain. So you're going to understand this a bit more better once we start working with the concepts of object-oriented programming. There are four of them. We're going to jump into them shortly. But um in when you're working with object-oriented programming, there are two things that you would hear about very commonly. You have your object and you have a class. So a class is a blueprint for creating objects that share a common set of attributes and methods. And in Python, when you want to define a class, you do so by calling the class method. So you just call class. So it's kind of like the way you would define function, but the name of the class is going to be defined with the first letter should be a capital letter. It might not be compulsory, but it's advisable. So you define your class, person, then you can now you need to initialize the so classes make contain attributes and method. Attributes define the properties of that class that you are creating, while methods define the actions that the class can carry out. So if you want to define the attributes, you have to initialize it. So you use the def init function. Then first thing you do is to call itself, so that for every object that is created from this class, it's going to like any once you assign attributes to that specific object, it's going to be unique to the object. So once you call the object, it's going to only get um the what do you call it, the attributes that have been defined for that specific object you are calling. So a person would have a name and an age. So these are the properties of this object. So we'll now need to initialize it to be like unique to that user. So we'll do self dot name, and we'll just so this name here, what we're doing here is we're just collecting parameters from the users. So the name parameter we collected is what we're going to put there now. Then we'll have self dot age, and we're going to assign the age parameter into that. So that is basically it. So now I've created properties for the current object or what for current class we're creating. Next thing you want to do is create method. So when you're creating methods, for every new method you want to define for that class, you use it you do so using functions. So you want to define a talking method because human beings can talk. We must always call self. Okay, they've already done it first. And then we just you can define it as you wish, but let's just get the name of the object we're currently working on. So it's going to be self dot name is talking. All right. So now next I want to do is create objects. So objects are created from a class. So if you want to define new object, you call the what you want to name the object as. Let's just say person one, and we want to inherit from a class. The name of the class we're working on is person. Class is collecting two variables from us. The first one you can see that's their prompting us. The self you can see is not asking us for self, so it's just asking us for name. and age. So the name we'll just use John, and for age we just use 33. Then if we want to access it, we have defined class, so we can now access, you know, methods from the class. So it's usually when you want to prompt it, especially if we are developing a game. So if you want to access the talk method in the class, we can say p1 dot the name of the method we're trying to access, and just save it. And if you run it, it should print that John is talking there. So that's just basic class, object and class. But I was saying there are four concepts of object oriented. Sorry, there are four concepts of object oriented programming. The first one we have inheritance, abstraction, polymorphism, and which one have I not called? Inheritance, abstraction, polymorphism, and why am I forgetting the last one? Encapsulation. So inheritance, as the name applies, is just the ability of a child class usually to inherit from a base class. So implementing inheritance is very, very, very easy. So now we have a class, we have a person class. This is a base class. So a base class is just called class and the name of the class. But if we want to now create another class that is supposed to inherit from this base class, we'll define class. It was almost going to be like how you did for this other one. Give it a name, let's say student. But now we're going to now have a parenthesis, and there we're going to call the class we're inheriting from. So let's say we want to inherit from person. Next we want to do is initialize the functions that are already the properties that are already unique to the person class, that's to the base class. So it's almost the same thing as when we did it for the first time. So we're going to just call dev our initialize function. Then we want to get for name and age. Next thing now, the way we're going to look about this is going to be a bit different. So there's this function that is that we're going to call, so it's going to be super. And we're just going to put in the attributes again. So basically the super parentheses dot underscore init method is called it allows the child classes to have access to the initialized attributes from the base class. That is all it does. It just gives the child class access to the attributes we got earlier. But now that I've done it, you can now go ahead and now define other methods for this student class. So this student class already has access to this talk class that was called earlier. Then we can go a step further and like add new classes for it and like to it on its own. So we can, let's say, what is going to be unique to it. So let's say def course. I think that is a method, but let's just do it self, and let's just print. Okay, let's define a new attribute that is unique only to this specific method. So then we can just collect course. Then we're just going to initialize it the way we did earlier without using the super, because this one is just unique to this. So it's going to be self dot course is going to be equal to course. Then we can now print the self dot name is studying self dot course. Right. Then let's define a new object. Let the object inherit from course instead. from students. So we have class, and for our course we have lesson. The method we want to go now is course. And I never noticed that I had named the function the same name as the variables. I've just corrected that. So I just changed it from course to courses. So yeah, so if you save it, you run it, it's going to give you journey studying whatever course it is that you put down there. So that is basically inheritance. And if you want to, if for some reason you're still not understand, you can just think about it as your parents. You have your dad, you have your mom. You inherit certain features from your moms, inherit certain features from your dad. It's not every single thing of theirs that you inherit, and it's not every single thing that you have that you inherited from them. Next, there is polymorphism. So this polymorphism tends to be a bit confusing, but polymorphism is the ability of objects of different classes to take on many different forms or behave in different ways. So it's just like based on the content where it's being used, it's going to affect how the method or the class or whatever how it acts. And there are two ways that polymorphism can be achieved. You can either use method overriding or method overloading. So in method overriding, this is the process of redefining a method in a subclass that already exists in the parent class. So this allows the subclass to inherit the behavior of the parent class while also providing its own implementation. Is a bit more similar to inheritance, which you just covered. So understanding should be a bit easier. So let's just work on something. So let's say we have a class. I want to get the area of the shape. So just going to be def area. Okay, and for now, let's just leave it vacant because every single shape has like different formulas for their own. So let's just cover some of the basic shapes. So let's create another class. Let's say rectangle. I'll spell that. It's going to inherit from shape, obviously. So this is how I need it. Alright. So now let's get the attributes. So we have so the area for a rectangle is a bit similar. So it's a bit simple. So it's going to be return. And let's just do another one for another shape. So let's say for circle. Now we'll create an object for each of the classes. We'll have for the rectangle. Now, basically, what we just did is in the base class where they're inheriting from, we defined um we defined a method which is the area method. But when we now inherited from those classes, we redefined it. So which is basically what we said about overriding. When you override something, you like replace what you currently have on file with something new. So we replace the function or the action that is going to be carried out um when the specific method is called. Then in method overloading, it's a process of defining multiple methods with the same name but different parameters. It's the ability of a method or function to behave differently based on the number or types of parameters or even the data type. Those are types of parameters passed to it. So in Python, we can achieve this um by using like default parameters. That is when you see when someone is asking for when they want to collect and parameters to give you like length is equals to and you pass in something, so your settings are default. Or you can use args and coax. Personally, I prefer using args and coax. So in args is arbitrary argument, while coax is keyword arbitrary argument. So args it saves whatever data that is collected into a list, so you can keep passing more data into it and it'll just be saving it as a list. It doesn't have a limit of amount of what it can collect, while quags saves it as a dictionary. So if you want to use default parameters, basically all you do is just you have class, you do def so why do I keep forgetting this? So let's say we want to have A, B, then just in case the user doesn't pass C, we cannot set a default value for C. So this is why this one is not going to work very well. It's because what if the user was to pass a fourth argument, your program is obviously going to crash. But if you just do return A plus B plus C, so we'll do two. So the first one we're going to pass two um we're going to pass two arguments, while the second one we're just going to pass one. So we have calc dot add, and we're going to have let's say just, and for the second one we're going to pass in, okay, let me change this C from 0 to something that will be easy to see the difference in. Then I just do the exact same thing, but this time we're going to pass in a third argument, and if you run it, it's going to successfully run. So like I said, if it's now passing a fourth argument into your program, it's going to crash the program. But if we're making use of args and quarks, our code is going to change a bit. So we're still going to have self, we're still going to have all the selves, but instead of having like the calling out the values individually, we're going to call args. Now that arg is just like definition of the word. I can use anything, but the main thing is if you want to call args, you must always have a single asterisk. Whilst if you want to call quarks is double asterisk, then you now have the name of what you want to call it. So that's literally like the name of the list or the name of dictionary. You can use args, it's not compulsory. I can use anything. I can use literally any word as long as I have that single asterisk in front of it. But now things are going to go a bit different. Now we're not just dealing with variables. We're working with a list. So we're going to say if um So we can say that is we can say for so we're just going to treat it as a list. So we're going to say for I in verse because that's what we called it. I'm just going to say let's call another variable up here. Let's say c and let's say c is equals to 0. So for I inverse, c is going to be plus equals to I, and then we're going to return c. So that's what we need to change. Every single thing else in your code remains the same. And if you run it, so I would advise, like, if you want to use overloading, I would advise to use args and coargs. Even like once you want to start like creating something, like I think we'll create this calculator app again. We did it before, so we're just going to work on it again. Then here we have best practices. Okay, let's just do that for now. Okay, then the next method, the third one, is abstraction. Abstraction is a key concept in object-oriented programming that allows developers to focus on essential details while hiding implementation details. So in abstraction, it's just like you can section parts of your code so that, like, depending on who is accessing it, there'll be certain things that will be hidden from them. Usually when you're working with abstraction in Python, we have a module that you're going to import. So it's the ABC module that is abstract base class. So we're going to say from ABC, we want to import. Don't worry, you don't need to install it. I think, yeah, you don't need to, it comes by default. So we're going to import the ABC class and we're going to import the abstract method. So when you define the class you want to work with, the class is going to inherit from this ABC class, which will make it automatically an abstract class. If you want a full video that dives into this abstract model better, you can let me know in the description below. But next thing, we're now going to call the abstract method, and we'll just leave it blank for now. So this kind of works a bit more similar to polymorphism, which we just covered earlier. So we can just go ahead and like just create subclasses from um from this shape class. Let's just create circle. Okay, so basically the main use of this abstract method is to just prevent the user from being able to create an object directly from the abstract class, that is in this case the shape class. So right now you may not really see the use of it because we have like we have like an empty method. If we had like more things that were going into it which we wanted to access, that will be like, so it will only be the developer that will be able to see like what the stuff is running on in the base class. But like at the front end, an object, you cannot create an object. So let's try creating an object for let's try creating an object for the shape class. Let's say s is equals to shape. I want to print um so it should give us an error. So you can see cannot instantiate abstract class shape with abstract method area. So the user will not be able to create an object with a class, but the developer who knows what the class is able to do can um, inherit methods and functions from that class and use it to create a class of their own, which the users would then be able to access and um, use. So that is basically what abstraction is. It allows you to hide complexity of your codes from the user so you can focus on the main part of your program. And this is like an easy way to like jump into the last one, which is encapsulation. So encapsulation is the concept that refers to the ability of object to control access to its internal data and methods. So it allows you to limit who can access specific features in your program. For example, when you have like admin, manager, and the user. So in Python, encapsulation is achieved through the use of access modifiers and properties. So we don't really have private and public methods in Python as you do in Java and other programming languages. But in Python, we do so using underscores, and I'm not talking about these double underscores. Those ones are dunder methods. I'm talking about those like double underscore init. Like, let me just like this one, this init. You have strings, so these ones are not the method I'm talking about. I'm talking about that if I was to define, didn't I just, what's happening? I'm talking about like if I was to define a function of my own, I can limit the access to it by using underscores. For example, if I had so if I were to have a class and let's just have so there are three main types of I don't know what call it, but like under access modifiers, there are three main types. The first one is the public ones, which is the one we've been using since. The second one is the protected ones. These ones are called with single underscore prefix, so that it comes before you define the variable name. So this one indicates that the variable method can be used within a class and subclasses, but not from outside the class. However, the variable or method can be accessed from outside the object if necessarily, so they are not exactly private. While if you use double underscore prefix, then it indicates that the variable or method should be treated as private and it should not be accessed from outside the class. So if you try to access it, it's going to like create like a name error because like the variable you're trying to access doesn't exist. It's possible to access it. There is still a way to access it, but it's like if you are making it private, why would you want to create a method for accessing it? So we'll just define each and every one of them. And so if you want to define for let me just do for the public one. And so I just finished creating the variables and the methods, and I've created an object from that class. So if let's say we wanted to access the methods within it, we can do it like easily like you would any other this stuff. So let's say for the public one, it's for you to just call it. You just say print and it prints it out. Then if let's say you wanted to use the same method to print out the private word, if let's print out protected without the under. Like, I don't know if you notice what am I doing? I don't know if you notice what happened. Let's see. When we did obj dot, if you notice, it suggested public, but we are not seeing the suggestions for the other methods because those methods are supposed to be hidden. So, but let's assume you just protected because according to our editor, it's as if the methods we created don't even exist. It's not showing, which is kind of like the main point of what you want. So it's supposed to be only people who are aware of that method you're trying to access that will now know to depend on if it's protected or private to put in the right underscore before you would now be able to run it and access it. And for the private is not even showing. Did I spell it correctly? So this is basically I said. So the public is available to general for general access. Protected is you don't exactly want people to have access to it, but it should be able to be accessed outside of the class. While the private, you shouldn't be able to access it at all. So okay, I said it was going to give you name error, generated attribute error. So if your class is defined as private, no one outside of that class should have access to it. But if you want people to be able to access it outside, then you use a protected um modifier. So it's very much straightforward. Another way that people usually go about this is making use of getters and setters. So these are like concepts using OP to allow the developers control access to your class attributes. So they are implemented using the property decorator. So I don't know if I've made a video on decorator, but when we call the abstract method using this art, that is a decorator. So the property decorator is just going to be at property. So a property is an attribute of a class that has the getter, setter, and deleter method associated with it. The getter method retrieves the current value of the property. The setter method sets the new value of the property if the user wants to change it or override it, and the deleter method deletes it. So just do a very simple. So if you have a class and we define, let's give it a name and an age. Say self dot name this name and self dot age is equals to age. So if you want to now make this class kind of like a protected class, a private class, you call the property you call the property decorator. Then before you start defining the what do you call it? So first thing we'll do is define the main function that allows us to have access to each of the individual properties. So you say def just names, which is one we're defining for names. You don't worry, you can name it the same. Then we're going to say return. So let's make this class let's make it protected. You can make it protected, you can use it private, however you feel. I'm just going to use a protected class. So say return. So this allows us to get, so this is the getter function. It allows us to get the value of this specific variable in question. Then if you want to be able to override it, so the way you do is now you call the name of this function that you have here. this name. So whatever your own is, that's what you call. So it's going to be at name dot setter. Then you're going to define the function again a bit similar. Use the same name also. So whatever name you used earlier, that's the same name you're going to use. And since we want to set a new value, we would have to collect the new value we want to set from the user, and then we're going to just set it just the same way you always override values, just equals to. Then you can just access it the way you would any other one. So this is going to be equals to, what did I call it again? Person. I'll just pass a name. Let me just leave age out of this for now. So if we were to say want to print, you can see it gives us access to it. But if this if this class that we define here now as private, and we, let's say we were to remove this now, and the user tried accessing this name, an error is going to be created. So that's basically it. So these are just, you can encapsulate it. So encapsulating is like just keeping it hidden from people who you don't have access to. So if you're working on a broader scale program now, you can say this code that we have here, you can put like maybe if if user equals to admin, then you can now set up this thing. Else you can like ignore it. So you now handle, you use try and accept error to now handle, so you know your program will not be crashing. But we're just doing everything straightforward so that you would have an idea of it. But those are all the concepts of object oriented programming. So yeah.